Last time you saw me tinkering with those 8-bit Ethernet cards on the IBM PC and PC XT, and we specifically explored this NE2000 reproduction card mainly because I ultimately wanted to give it a shot with Linux on the IB. Oops. Let's go back to where Linux began. I'm the vintage collector, and these are my stories. See, the reason I ended up in this situation here is simply because the IBM PC 5150 ran out of memory. 256K is simply not enough to—
Hold it. The IBM PC had an 8088 CPU, but Linux was written specifically for the 386.
True that, but in 1995 Chad Page and Alan Cox began implementing what then was still called Linux 8086 until it eventually got a new name: ELKS. ELKS stands for Embebbable Linux Kernel Subset. It began as an early fork of Linux for 16-bit CPUs, including the 8086, the 8088 and NEC V20 and V30 compatible processors. That matters here because a stock IBM PC or PC XT is exactly the kind of machine mainline Linux does not target. ELKS does not require a hardware MMU, and current stock images notably run in systems with 512K of RAM, while the kernel itself can run with as little as 256K. For ARM-based systems, the project even lists 128K as possible. But as we just saw, even if the kernel can boot in 256K of RAM, it's not enough to start init and bring up the user land. So that puts both my IBM PC and the PC XT out of reach, as both have only 256K. But my IBM PC Portable 5155 has 512K, so that should work. And in favor to my network exploration, I had to specifically transplant the open source NE2000 card from the IBM PC to the Portable. Reason number 1, ELKS only supports 3 network cards: the Western Digital WD-8003 and AT13. These 3 come Etherlink 3, neither of which I have, and straight NE2000 cards. That means my original and period correct 8-bit cards, as seen in the last episode, are also out of question. Now, ELKS is actively maintained, with the latest release being 0.9.1 dated May 5, 2026. There are a number of images readily available, but for my machine I'm confined to using the 360K floppy image. ELKS disk images are usually provided in both FAT and MINIX formats. We'll see a creative kind of abuse of a FAT image later on, but for my regular exploration I went with the MINIX image. But before turning to ELKS, let's install that card in the machine. I figured that the bezel that came with the card was quite wobbly. This caused some problems when trying to fit the card into the slot. So I went reprinting a replacement, but even my own attempt turned out to be not as solid as I had hoped for. So I went to use a carbon fiber reinforced PET-G, which gave it a more solid feel. Opening the IBM PC Portable is an experience of its own. As compared to the desktop PCs, this one has a lot of shielding on the inside. Once I had removed the cage cover, I plugged in the network card and, well, it was not recognized in DOS, neither by the packet driver nor by the RZ8019 configuration utility. At first I suspected the usual things: address, interrupt, but I knew it should work as I came from running in the exact same configuration on the IBM PC. But the actual mistake was much simpler. I had put the card into slot 8. On the IBM PC XT, slot 8 is the one closest to the power supply. On the Portable, the layout is different, and I simply did not pay attention to which slot I was using. And slot 8 is not a normal expansion slot. Some say it was intended for the IBM 5161 expansion unit extender card, but that claim is not true. However, most ordinary ISO cards do not work there unless they specifically support it. So after moving the NE2000 card to another slot, it was recognized. Well, so much so about slot 8. Another one I looked into while I was at it was error 1801 reported during post. Not strictly speaking an error, but more like a warning, and it was caused by this expansion card being installed in the system. This card is used for connecting the external 5161 expansion chassis if you happen to have one. And the IBM PC Portable proves that this particular card does not need to be equipped to slot 8, as in this machine it sits in slot 2. Now, I don't have the expansion chassis, so I pragmatically removed the card from the system to get rid of the superfluous post-error message. With that settled, I turned to booting ELKS for the first time on this machine. And see, even if 512K is rather scarce, it's plenty to make the system come up. It drops you into a shell where you'll find some familiar Unix tools, but of course, given the small footprint of the 360K floppy disk, many are missing: no top, no dmask, no ifconfig. And even though ELKS supports TCP/IP, the required binary file was absent from the floppy disk too. So now what? I guess I need to install some mass storage in the system to at least do anything useful with it. Given all the integrated design of the IBM PC Portable, there's no way to fit the contemporary full-height hard drive inside unless I remove the floppy drives, but I prefer to keep those. However, there's actually enough room for retrofitting this XT-IDE Compact Flash adapter. Now, either you use an external bezel to be able to switch the CF card from the outside, or you use an internal adapter. Either way works. Coming back to the slot 8 topic, this adapter in fact has a jumper setting to allow it to run when equipped to slot 8. But since the CF adapter is quite wide, I placed it in slot 7 instead. Mind that I added a small label to remind me of slot 8 for the future, should I ever forget about it again. With the XT-IDE equipped, I then first installed PC-DOS 3 just because I might need that one sometime in the near future again. DOS lives in the first partition, or /dev/HDA1 in Linux terms. Now, how about installing ELKS to a hard drive, or rather to compact flash as in my case? There are good instructions around that, which basically involve fdisk, creating new partitions and formatting them. So I started off by creating new MINIX partition /dev/HDA2 which will host ELKS. But wait, ELKS doesn't provide installable disk sets, they're just the boot floppies. So how would I add all the extra tools I need? Because after all, the TCP/IP part is missing from the boot floppy disk for space reasons, so I can't even download the rest over the network. The official way would be to transfer your disk image onto the flash disk from another system. So I could of course do that, but I decided to take another route. So I added another fat partition as /dev/HDA3 with 60 MB in size, big enough to hold that 30 MB ELKS hard disk image. Then, on my Mac, I copied the disk image file onto the FAT partition. Back on ELKS, I mounted /dev/HDA3 to then transfer the hard disk image into the previously created /dev/HDA2 ELKS partition. But again, I tripped over the 360K floppy disk limitation, as the DD utility was not included either. Okay, so where to borrow it from, unless you really want to compile the source locally yourself? Remember how I mentioned earlier on that ELKS also provides fat disk images. So I downloaded one of those and opened it in WinImage. From there I copied DD over onto the HDA3 partition on the compact flash. And with that I ran DD off the compact flash, essentially dumping the MINIX image into the /f/HDA2 partition. But I had to fight a bit with DD to figure out which one was the largest valid block size for the transfer, which turned out to be 8K. As mentioned, you could dump the image using DD directly onto the flash, but I deliberately wanted to see how long it takes. Turns out, writing the entire 30 MB disk image took almost 1 hour. So that's a rough 9.5 KB per second. Okay, I wasn't benchmarking here, I was only curious how long it would take. At last, don't forget to run the make boot command, so the partition geometry will be fixed. In direct comparison, booting off the flash takes just below 8 seconds, whereas booting off the floppy disk takes about 30 seconds. No surprise, the flash is significantly faster. And yes, the disk image brings a lot more, including the IP stack. So let's see what we need to do to configure TCP/IP. Now, during startup, you'll notice how the kernel looks for certain network cards, and at this stage it'll detect neither of the supported ones. No wonder, as it uses default values. Like on DOS, we'll need to point the kernel at the correct IQ and I address, which can be done by editing the /bootopt file. There, I set IRQ3 and I address 300 hex for the NE0 card. You'll also need to uncomment the net statement and point it to NE0. As ELKS doesn't bring a DHCP client, you'll also need to edit /etc/net.config to provide the correct IP address configuration. But on the next startup, the card was still not detected. Maybe it wasn't compatible with ELKS after all. But no, it turned out to be a very basic problem. See here which I address the XT-CF adapter reports. Right, 300 hex. And which I address did I use for the Ethernet card? Indeed, it's again 300 hex. This is the classic case of manual resource configuration. We have a resource conflict here. And since the I/O address of the XT-CF adapter can't be changed, I had to switch it on the network card, which now uses 320 hex. And that was it. The system comes up, recognizes the card, and I can finally reach the machine over the network. Now there is a net show command which tells you the current config. And while there are familiar tools like the ARP command and netstat available, others like ifconfig are missing. By default, ELKS KTCP starts telnet and FTP, so it is possible to access the machine remotely over the network. However, RAM is thin at 512K, so you must expect occasional out-of-memory errors. ELKS also brings an FTP client, so it can download files onto the machine from an FTP server. But the client is very limited and doesn't provide stats during transfers, so I have no idea what my current throughput is. It can't be much, however. So I uploaded a file over FTP from my Mac onto the IBM PC Portable, which reportedly gave me around 3.5 kilobytes per second, which translates to roughly 28 kilobits per second. Now, that's actually a lot less than I had expected. I had hoped to reach at least somewhere around 30 or 40 kilobytes per second, so somewhere between 240 and 320 kilobits. It would probably work better with more RAM available, as the logs revealed several times how the FTP server failed to fork, which constantly put back pressure on my FTP client to restart transfers. But hey, no criticism here, because running a trimmed down Linux on an 8088 machine with TCP/IP plus some servers in just 512K of RAM is pretty darn impressive. ELKS even brings an HTTP server, so you can serve up simple pages, and if you dare, you can even connect it to the internet. But that's a story for another time. What about you? Did you ever try out ELKS, and what was your experience with it? Let me know in the comments below. And if you like these retro explorations, be sure to subscribe. I'm the Vintage Collector, and this was my story for today. Thanks for watching, and see you again next Sunday.